All right, guys, so this is section 2.1, and what we're looking at is sometimes you're going to find that there's solution curves without any solutions, meaning that we try to find solutions, but we cannot. We wind up getting, unsolvable equations so that we really don't have a solution here. So sometimes you can, sometimes you can't. Basically, very simple. But what you still can tell is how the solution behaves, all right? And by looking at two different things, one would be direction fields is the first one. So that's in 2.1.1, and these are called slope fields. So now, thinking about slope fields or directional fields is kind of like a derivative is always going to give us a slope of the tangent line of a curve at a given point. And then it will create these little slope fields kind of telling us direction that the function is going if we have it given at a given point. So we're going to do this example here where you have a differential of x times y squared, and when we want to see how does this thing behave, okay? So let me just mark off. Okay, so let's look at the x-axis. So on the x-axis, right, just think of plugging in y to be 0 into our differential, and this would give us a slope of 0. So our x-axis, all I'm going to do is put little dashes at given points where the slope is 0, and that'll continue on forever. And the same thing goes with the y-axis as well. If you're plugging in x to be 0, we're going to still get a derivative of 0, which means that our slopes are going to be 0 on both axes, okay? Now, in quadrant 1, let's highlight some of these. So you got x-axis, y-axis, and now we're going to do quadrant 1. Think about x and y both being positive. So that means your slopes are always going to be positive. All right, and then specifically to see how steep, just pick a point in that quadrant. So like 1, 1, what would your slope be? So my slope would be 1 if I plug that into dy dx. And then try your best to have a dash at 1, 1 with the slope, with that little dash having a slope of 1. And then you could continue on, right? So if it's 2, 1, right, our slope would be 2, right? So you want to try to make it a little steeper, right? Maybe not that steep. That looks too steep. But maybe like that, right? And you could continue this on. So 3, 1, it would even have a steeper slope, right? Something like that. And then this would continue. So you could see as you start plugging in. So 1, 2, you would have a slope of 4 and then a slope of 9. So that's almost vertical, right? And as you go along, you can see that these slopes are just going to get steeper and steeper here, right? So this is there. So just trying to exaggerate as best you can. I mean, it doesn't have to be perfect. In quadrant 2, right, you know you're going to have negative slopes because x is negative and y is positive, right? So it's the same idea. You could do the same table. I'm just going to do this quickly where here I would have a -1 slope, right? As I go up, be a -2, and then, I'm sorry, -4, and then -9. I probably should make that a little bit steeper, right? So like that, and then you're exaggerating as these slopes get basically almost vertical. Okay, and you can see how it has kind of like a pattern that we're looking at here. Okay, third quadrant, still negative because you'll have negative x, but the y squared will make everything positive. So again, you have something very similar, right? This will go up to -2 and then -3. I mean, sometimes these are tough. I kind of want to exaggerate a little bit more, right? And then steeper yet, right? So trying to be consistent here. Okay, fourth quadrant, always positive. So here we would have a slope of 2, right? And here we would have a slope of 3. So you can see how I'm gradually making these slopes a little bit bigger, but this is a slope field. This is what we have and what we're going to be looking at. But as they get steeper and steeper, it's a little weird on how it would look, but you just want to try to stay consistent with the steepness. All right. The next thing that we could do is, let's say we want to look what's going on at a given point. So say our function, our initial value, is at the point 0, 1, right? What you could do is kind of show how this graph behaves. So here you could see, plot the point and then just follow the slope fields. Try not to go and touch the exact point, almost like you're going through, but you can see you're following those slope fields, right? So that would be the red function. Let's say we have y of -1, -2, right? So -1 gives us -2. And what would this look like? So remember, your x-axis has a slope of 0, so it's kind of like going to flatten out right about there, where it's going to come and flatten out at 0. So it'll look like, you know, something like that, where it starts to flatten out and give you a slope of 0. And then, whoops, I didn't want to put that arrow. Okay, so once it does that, and then it's going to continue going up, okay? On this side, it's just going to continue and following slopes, right? So then it'll look like that. Okay, but just making sure it's kind of almost flattening out. I probably should make this go up a little more. You know what, let's try this again. So you're coming up, slope of 0, and then follow, right? This one's going down, slope of 0, come through, slope of 0, and then follow it up. Okay, so you could see how that's going to look with that slope equation there, almost like it's going to be an even function, right? But you can see how the graph would look with those little slopes, right? And then kind of guiding your way through. All right, so that's slope fields.